Hi, welcome to my video on circles, and that's inscribed central angles and arcs number 2. An inscribed or central angle intercepts or cuts off the circumference of the circle. When the angle is named by 3 letters, the first and last letters are the letters of the intercepted arcs. And the reason I define it this way, because a lot of students find it confusing picking up the inscribed angle and the central angle. So let's go through how I do it. We have a circle, center O. O is the center of the circle right here. And it says the central angle BOC intercepts arc BC. So the central angle BOC intercepts this arc. Notice that BOC, the arc, is BC, first and last letters of the angle. The inscribed angle is BAP, intercepts the arc BP. So the inscribed angle is made up of 2 chords with a common endpoint. So the common endpoint is A. So BAP is an inscribed angle intercepting the arc BP. So notice B and P are the first and last letters of the angle when you name it with 3 letters. Now I have another diagram. O is the center of the circle. BC is the diameter. And it's a chord going through the middle. And we're going to fill in the blanks based on this diagram. Fill in the blanks. Angle ABC intercepts arc. So angle ABC is cutting off the arc AC. It's the first and the last letters in the angle. The angle, which angle intercepts the arc BT? So BT is this arc right here. So this is BT arc. So the angle that intercepts this arc is the angle BAT. So the angle is BAT. And again, that angle, the B and the T are the first and last letters. And notice that BAT is an inscribed angle because it has 2 chords with a common vertex. And the angle BOR intercepts arc. So let's find the angle BOR. BOR is this angle right here, and is intercepting, again, BR. BR is the minor arc because there's 180 here, so this is less than 180. If you want to get the major arc, then you get the other side of that angle, which is this right around here. So the arc is BTR. So you could have BTR. You could have, it's also called, you could have BAR, or you could have BCR. All of them, because we want this arc to be BR and we want a major, then you can pick the T, the A, or the C to be in the middle, because they all represent the same arc of B right around to R. And again, at the end, all of these end in the first and the last letters is the arc that they intercept BR. And an angle intercepts arc CR. So CR is this arc. So what angle intercepts? So it has to start it and it has to end it. So the angle is COR. The angle COR is a central angle that cuts off this arc. And again, C and R are the first and last letters of this angle. That's the arc that is cutting out. Okay, let's continue. O is the center of the circle. TB is a chord. So we have this diagram. O is the center. TB is a chord. But notice I said it's a chord. I didn't say it was the diameter, but it is the diameter, because a chord that passes through the center is a diameter. Now, fill in the blanks based on this diagram. The central angle intercepts arc AB. What central angle intercepts the arc AB? So here's the arc AB. So it's angle. That's AB. A is the first letter. B is the last letter. So the central angle is AOB, because central angle is made up of two radii meeting at the center. An inscribed angle intercepts what inscribed angle intercepting arc AB? Again, there's an inscribed angle, so the angle starts with A, ends at B, and is an inscribed angle. So an inscribed angle is made up of two chords. So it's ATB. Again, ATB, chord TA, chord TB, and this is the common vertex. Arcs formed by T, A, and B, which are major. So arcs which are formed by T, A, and B, which are major. So major arcs got to be more than 180. So TA and B's arcs, so let's go. You could go A, all the way around like this, ATB is a major arc, because it's leave A, go all the way around. That's 180 here. So when you leave and go this much plus 180, you got a major arc. And another major arc, we can go the other way. So we can go A, B, T is a major arc. A, B, T, there's the 180 here. So when I go this much, this is a major arc made up of these three letters. D, arc TA is intercepted by the central angle. Arc TA intercepted by the central angle. So this is the arc TA. So we want a central angle, which is here. So it's TOA is the central angle intercepting this arc. So it's the angle. It starts off with a T, goes to the middle because it's central, and ends with an A. TA is intercepted by an inscribed angle. Again, the angle starts with T, ends in A. So we want an inscribed angle. So it's TBA is an inscribed angle. Remember, central angle, TOA, is an angle that's at the center made up of two radii. An inscribed angle is made up of two chords, and the vertex is on the circle. So the two chords meet at B. So this is an inscribed angle. Chord, chord, inscribed angle. And we have another diagram. We have a diagram here, which O is the center. O is the center. It says that HV is a chord. So HV is a chord. Again, because this is a chord going through the middle, that means that HV is a diameter. I just wrote down chord, and you had to come up with, that's a diameter, so that's 180 degrees. So this angle, HOV, the angle HOV is 180 degrees because that's a straight angle. Now, if this is a straight angle, if this is a chord, which is the diameter, then this arc here, to measure up the arc VKH or VNH, so the arc VNH is 180 degrees. And the arc HKV is also 180 degrees, because this is the diameter, so each part here is a semicircle. And you notice that these are all equal. So the measure of the central angle is HOV, is equal to, so the central angle, which is in the middle, going through here, is equal to the interceptive arcs of, we could say arc VNH, and is equal to the arc HKV. So this central angle, because of 180 degrees, which makes this semicircle, so these two major arcs, this one and this one, are both equal to the central angle. Okay, let's continue. We have another diagram, and we have, in this diagram, we have O as the center, and And notice that O is marked as the center. This is perpendicular here. So the diameter, this is the diameter, is a chord that's going through the center. This is the diameter, a chord going through the center. So the diameters are blank to each other. So the diameters are perpendicular to each other. So because the diagonals are perpendicular to each other, we have that the angle VOY, the angle VOY is 90 degrees. The angle VOY is an inscribed or central angle. It's a central angle. Now, the arc, because these are two diameters intersecting perpendicular, the arc VY is equal to 90 degrees. These two diameters are cutting each other perpendicular to each other, so that makes this arc 90 degrees. Now, that means that the angle VOY and the arc VY have measures of 90 degrees. What I'm trying to say is the measure of the central angle equals the measure of the intercepted arc. So the central angle, the angle at the center is always equal to, no matter what the angle is, it's always equal to the measure of this arc. And I use the diameters perpendicular to each other, say I got a 90 here, I got a 90 here, so this angle in here is equal to this arc. This angle is a 90, is equal to the measure of this arc. This angle right here is 90, is equal to the measure of this arc, and so on. This angle is 90, equal to measure of this arc. So let's do some problem based on the central angle equals the measure of the intercepted arc. O is the center of each of these circles here. I want to make sure of that. So it says that HOF is 40. Angle HOF is 40. Angle HOF is 40. So that's a 40-degree angle. That means that the arc HF is 40, because the measure of the central angle is equal to the measure of the arc that it intercepts. That means that this arc is 40. That means the arc HXF all the way around the circle is 360. So this arc is 40. So when you subtract, you get 320. So the arc HXF is 320 degrees. Number 2, we have a circle. Again, the center is O, and we have a triangle. Notice in the triangle, this is the center. So this triangle, we have OA equals OB. And the reason these are equal, because the radii of a circle are equal. So we have angle ABO equals 30. So ABO, so this angle is 30 degrees. Because these two sides are equal, that means these two angles are equal. If two sides are equal, two angles are equal. That's the ITT theorem that we did in proofs on congruent triangles. So because that means that angle AOB is obtuse, angle AOB. So we have 180 degrees in a triangle. So that means we got 30 and 30 makes 60. So when we subtract, that means that the angle AOB is 120 degrees. Now I said, you might say, well, why did I say obtuse? Because remember, the angle A, because we have a circle, AOB could be this angle, or AOB could be this, what we call reflex angle, more than 180. So I said AOB was obtuse. That means this is the one I'm talking about right here, to make it 120, because this one over here is 360 to go all the way around this arc that you're going to see now in a minute. You're going to say, that's why I said this one is 120, obtuse. So that means the arc AB is minor, so it is equal to the central angle. So that means this arc AB is 2 letters. It's a minor, and a minor is less than 180. So that means the arc AYB is 360 minus the 120. And so that's a 240 degrees. So that's 240. So there it is. 240 is over here, which is all what's left. So 240, add on 120 is 360. Number 3, again, O is the center of the circle. And I said this arc here is 2x. This arc right here is x plus 60. And this arc right here is 3x. So that means if I take x plus 60, and that's the degree, I'll leave off the degree symbol there. And I add up, if I add up all these arcs, they all add up to 360 degrees. So if I add x, 2x, and 3x, so that's 6x plus 60 equals 360. So I'll put the degree in. So 6x is equal to 360 minus 60. 6x is equal to 300. Divide by 6. X is equal to 50 degrees. And so x is equal to 50. So that means because I have x is 50, I can get the measure of this arc. I can get the measure of this arc. So 3 times 50, 2 times 50, 50 plus 60. But we want the angle that's IOL. So the arc IL, the arc IL is 3x, and x is 50. So the arc is 150. So this angle, IOL, is cutting off this arc. So that means that the angle is 150 degrees because the central angle is the same size as the intercepted arc. So there's a few diagrams and some properties that, notice I'm working on a few, only one or two properties at a time to make sure everything is explained. And I'll use diagrams and problems to bring out that understanding. And if you like my video, click on the like button, click on the subscribe button. If you want to be a subscriber to my channel, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.